for you. You're going to learn how to solve a real-world problem using machine learning and Python. We're going to start off with a brief introduction to machine learning. Then we're going to talk about the tools you need. And after that, we're going to jump straight into the problem we're going to solve. You will learn how to build a model that can learn and predict the kind of music people like. So by the end of this 1-hour tutorial, you will have a good understanding of machine learning basics, and you'll be able to learn more intermediate to advanced level concepts. You don't need any prior knowledge in machine learning, but you need to know Python fairly well. If you don't, I've got a couple of tutorials for you here on my channel. The links are below this video. I'm Mosh Hamadani, and I'm super excited to be your instructor. On this channel, I have tons of programming tutorials that you might find helpful. So be sure to subscribe as I upload new tutorials every week. Now let's jump in and get started.
My job is to make college easier because students have a lot on their.
In this section, you're going to learn about machine learning, which is a subset of AI or artificial intelligence. It's one of the trending topics in the world these days, and it's going to have a lot of applications in the future. Here's an example. Imagine I ask you to write a program to scan an image and tell if it's a cat or a dog. If you want to build this program using traditional programming techniques, your program is going to get overly complex. You will have to come up with lots of rules to look for specific curves, edges, and colors in an image to tell if it's a cat or a dog. But if I give you a black and white photo, your rules may not work. They may break. Then you'll have to rewrite them. Or I may give you a picture of a cat or a dog from a different angle that you did not predict before. So solving this problem using traditional programming techniques is going to get overly complex or sometimes impossible. Now, to make the matter worse, what if in the future I ask you to extend this program such that it supports 3 kinds of animals: cats, dogs, and horses? Once again, you'll have to rewrite all those rules. That's not going to work. So machine learning is a technique to solve these kind of problems. And this is how it works. We build a model or an engine and give it lots and lots of data. For example, we give it thousands or tens of thousands of pictures of cats and dogs. Our model will then find and learn patterns in the input data, so we can give it a new picture of a cat that it hasn't seen before and ask it, is it a cat or a dog or a horse? And it will tell us with a certain level of accuracy. The more input data we give it, the more accurate our model is going to be. So that was a very basic example. But machine learning has other applications in self-driving cars, robotics, language processing, vision processing, forecasting things like stock market trends and the weather, games, and so on. So that's the basic idea about machine learning. Next, we'll look at machine learning in action. A machine learning project involves a number of steps. The first step is to import our data, which often comes in the form of a CSV file. You might have a database with lots of data. We can simply export that data and store it in a CSV file for the purpose of our machine learning project. So we import our data. Next, we need to clean it. And this involves tasks such as removing duplicated data. If you have duplicates in the data, we don't want to feed this to our model, because otherwise our model will learn bad patterns in the data and it will produce the wrong result. So we should make sure that our input data is in a good and clean shape. If there are data that is irrelevant, we should remove them. If they're duplicated or incomplete, we can remove or modify them. If our data is text-based, like the name of countries or genres of music or cats and dogs, we need to convert them to numerical values. So this step really depends on the kind of data we're working with. Every project is different. Now that we have a clean data set, we need to split it into 2 segments. One for training our model and the other for testing it to make sure that our model produces the right result. For example, if you have 1,000 pictures of cats and dogs, we can reserve 80% for training and the other 20% for testing. The next step is to create a model, and this involves selecting an algorithm to analyze the data. There are so many different machine learning algorithms out there, such as decision trees, neural networks, and so on. Each algorithm has pros and cons in terms of accuracy and performance. So the algorithm you choose depends on the kind of problem you're trying to solve and your input data. Now, the good news is that we don't have to explicitly program an algorithm. There are libraries out there that provide these algorithms. One of the most popular ones, which we're going to look at in this tutorial, is scikit-learn. So we build a model using an algorithm. Next, we need to train our model. So we feed it our training data. Our model will then look for the patterns in the data. So next, we can ask it to make predictions. Back to our example of cats and dogs, we can ask our model, is this a cat or a dog? And our model will make a prediction. Now, the prediction is not always accurate. In fact, when you start out, it's very likely that your predictions are inaccurate. So we need to evaluate the predictions and measure their accuracy. Then we need to get back to our model and either select a different algorithm that is going to produce a more accurate result for the kind of problem we're trying to solve, or fine-tune the parameters of our model. So each algorithm has parameters that we can modify to optimize the accuracy. So these are the high-level steps that you follow in a machine learning project. Next, we'll look at the libraries and tools for machine learning. In this lecture, we're going to look at the popular Python libraries that we use in machine learning projects. The first one is NumPy, which provides a multi-dimensional array. Very, very popular library. The second one is Pandas, which is a data analysis library that provides a concept called data frame. A data frame is a two-dimensional data structure similar to an Excel spreadsheet. So we have rows and columns. We can select data in a row or a column or a range of rows and columns. Again, very, very popular in machine learning and data science projects. The third library is Matplotlib, which is a two-dimensional plotting library for creating graphs and plots. The next library is scikit-learn, which is one of the most popular machine learning libraries that provides all these common algorithms like decision trees, neural networks, and so on.
Foldable design that takes 3 seconds to collapse. Rundeer's battery constitutes 1/3 of the total cost of the vehicle. It uses a premium battery cell material as the global standard to achieve 35.
Now, when working with machine learning projects, we use an environment called Jupyter for writing our code. Technically, we can still use VS Code or any other code editors, but these editors are not ideal for machine learning projects because we frequently need to inspect the data, and that is really hard in environments like VS Code and Terminal. If you're working with a table of 10 or 20 columns, visualizing this data in a terminal window is really, really difficult and messy. So that's why we use Jupyter. It makes it really easy to inspect our data. Now, to install Jupyter, we're going to use a platform called Anaconda. So head over to anaconda.com/download. On this page, you can download Anaconda distribution for your operating system. So we have distributions for Windows, Mac, and Linux. So let's go ahead and install Anaconda for Python 3.7. Download. All right, so here's Anaconda downloaded on my machine. Let's double click this. All right, first it's going to run a program to determine if the software can be installed. So let's continue. And once again, continue. Pretty easy. Continue one more time. I agree with the license agreement. Okay. You can use the default installation location, so don't worry about that. Just click install. Give it a few seconds. Now, the beautiful thing about Anaconda is that it will install Jupyter, as well as all those popular data science libraries like NumPy, Pandas, and so on. So we don't have to manually install this using pip. All right, now as part of the next step, Anaconda is suggesting to install Microsoft VS Code. We already have this on our machine, so we don't have to install it. We can go with continue and close the installation. Now, finally, we can move this to trash because we don't need this installer in the future. All right, now open up a terminal window and type Jupyter with a Y space notebook. This will start the notebook server on your machine. So enter. There you go. This will start the notebook server on your machine. You can see these default messages here. Don't worry about them. Now it automatically opens a browser window pointing to localhost port 8888. This is what we call Jupyter dashboard. On this dashboard, we have a few tabs. The first tab is the Files tab. And by default, this points to your home directory. Mac, you can see here